Okay, so hey everyone, out here in the back. My name's Josh. I'm from the TensorFlow team in Google, New York. I also teach machine learning at a couple universities at night, which is really, really fun. And so TensorFlow, it's an open source deep learning framework. From an educational perspective, there are many wonderful open source deep learning frameworks. You might also have heard of Keras or PyTorch or scikit-learn or MXNet or Chainer. And my general advice to students who are starting out in machine learning or deep learning is that it takes an enormous effort to learn one. And after you've learned one of these frameworks, it's much, much easier to learn any other. We like to describe deep learning these days as concept heavy but code light. So for instance, if you're learning about image classifiers, as we'll try and do tomorrow during the workshop, it will take quite a while to understand what on earth is convolution and what is a convolutional neural network and how does a series of filters learn increasingly abstract patterns? But all those concepts end up being basically a single line of code in practice. And that single line of code you'll see looks almost identical today, regardless of which framework you're using. So that's great. So first of all, for people teaching or considering teaching machine learning classes at any level, I just had a couple of recommendations for you. And the first is, oftentimes you do need a GPU for deep learning. It can make your experiments run 20 times faster. The good news is today, no one needs to spend any money to use a GPU in an educational setting. So if you're new to it, I'd highly recommend checking out Colab, which is short for Collaboratory. It's a tool from Google Research. It's a free Jupyter Notebook environment that runs in the cloud. There's zero setup. You can't pay for it even if you want to. And it includes a GPU. And all of the tutorials on TensorFlow.org are open source notebooks on GitHub, but you can run them in Colab, so they run quickly, and it's easier for students to set up and install. So Colab is wonderful. If you'd like a book, there is currently only one book that I'm familiar with on TensorFlow 2. TensorFlow itself was the first large-scale industrial deep learning framework, and it was open sourced by Google in 2015. At this point, we're really fortunate to have something like 1,300 people from outside of Alphabet who have contributed code. So it's enormous. And one cool thing about TensorFlow, it's also, it's the world's most complex framework by far, meaning it spans Python, JavaScript, Android, iOS, Raspberry Pi, CPUs, GPUs, TPUs, 2 seconds. And it can take a little while to learn because of that. But I'd like to show you some simple ways to get started with Python in a sec. And then finally, for PhD students, faculty, postdocs, anyone interested in teaching ML, Google AI and the TensorFlow team are going to be publishing a request for proposals in the next probably month or so. We're just trying to finish it up. And we can partially support people teaching new machine learning classes. It's a relatively small amount of funding, but we're here to help and also give you advice on educational resources and stuff like that. So if you're interested, please shoot me an email, and I'll share it with you as soon as it's ready. Anyway, I'm going to make this diagram clear in a sec. So one really, really cool thing about TensorFlow 2 is that it's entirely about ease of use. And we have a large number of users, everyone from complete beginners who are brand new to deep learning all the way through world-class researchers. And what's one nice thing is all of these people can use the same framework. And the way we accomplish that is we have different levels of code abstraction for different needs. So if you're brand new to this, we have a very, very simple API called Keras, which is really elegant. It's incorporated into TensorFlow 2, and it means you can write and train your neural network in 5 lines of code. And I'll show you that in a second. If you're a researcher and you want control and flexibility, we have a Chainer-inspired API called Model Subclassing that I'll also show you, and you can write your training loop from scratch without having to leave the framework. So just quickly, here's what this stuff looks like. So if you go to tensorflow.org/tutorials, and you're new to all this stuff, by far the best place to start is Machine Learning Basics with Keras. And these are very detailed walkthroughs. But I just want to show you very briefly what these quick starts look like. And quick start for beginners, which I'd love to improve, but it's a solid basic code example. This is showing you how to write a complete neural network. And creating the model itself is just these 5 or 6 lines of codes. And this is a fancy one. It uses dropout as well. But here what we're doing is we're defining a neural network as a stack of layers. And here we have 2 dense layers. So this is a neural network with a single hidden layer. And we're using dropout, which is a fancy feature to prevent overfitting. So we define the network. And what I mean by concept heavy but code light here's where we specify the loss function and how we want gradient descent to work. And there's all sorts of different ways of doing gradient descent, everything from the basics to super fancy optimizers like Atom, but using them in practice is just one line of code. And then we can train the entire network in a single line. And so this is our beginner style. And so that's the complete code for deep learning. There's not much to it. And you can spend your time learning. The reason I mentioned collaboratory is you can download this on GitHub, or you can open it up in Colab. And Colab is reading this directly from GitHub. And if you want a GPU, you can go to Edit, Notebook Settings, Hardware Accelerator GPU. We also have free TPUs available, but at the moment, TPUs require a small amount of code changes where GPUs just work perfectly with TensorFlow 2. So you pick a GPU, you hit Save, connect, and you'll be connected to a virtual machine on Google Cloud with a GPU where you can run this code. And it's good for, it's not published, but it's about 12 hours a day. So basically you have as much GPU time as you would realistically want, unless you're mining Bitcoin or something like that, in which case it will disconnect you. So anyway, that's our beginner style. And then to run these code cells, it's exactly like Jupyter. You can just step through it and whatnot. So this is perfect for students, and I use it in a lot of my classes. And then I also just wanted to briefly show you, so what you just saw here was the sequential API and built-in layers. And then for researchers, I'd like to show you a different style that does exactly the same thing. If we go to Quick Start for experts, you can also define your model this way. And this will feel really familiar to Java programmers. Here, what we're doing, instead of defining the model as a stack of layers, what we're doing is extending a class. And in the constructor, you define your layers. And in the call method, you define how the data flows through it. And because this is TensorFlow 2, it's imperative, just like Python, it's interactive. If you're a researcher and you'd like to see exactly the output of this particular dense layer, you just write print x beneath it, and you'll see exactly what the data looks like as it flows through it. So this is completely hackable. Another nice thing about our expert style is in the beginners, we trained our model with model.fit. But maybe you're a mathematician and you're writing a new gradient descent optimizer and you'd like to see exactly what the gradients are so you can work with them. In our experts example, instead of model.fit, we've written this. And this is a complete training loop from scratch. What we're doing is we're calling the model on some data, we're calculating the loss, and here's where TensorFlow does autodiff. We're getting the gradients of the loss with respect to all the variables in the model. And you can print them out, and there are the gradients, and you can modify them however you like. So basically, that's what TensorFlow 2 looks like in Python. And anyway, I wanted to briefly show you some really awesome things that you can use with kids or you can use yourself. And these are all interactive demos and games built with TensorFlow JS, which is great. It's js.tensorflow.org. The last talk, which is great, mentioned the Teachable Machine. And if my Wi-Fi is working, I can actually show you exactly what this looks like. So this is a way to quickly train an image classifier in the browser. And this is built with TensorFlow JS. And the first version of it actually used something called k-nearest neighbors on top of a convolutional neural network. I believe this newer version is actually training a network in the browser. But if you haven't seen this live, the way this is going to work is we'll quickly collect a few examples and be awkwardly standing here with the mic. And then we'll get a second class. And the second class will just be no one here at all. So now we have some training data, and we can train the model. I don't need a tutorial, I just want to train it. And today is a slow day for my laptop, apparently. Well, you can see how well this works. Usually it's quite good, trust me. But maybe while that's training, I'll flip to something else. We might be having a bad day with Josh's laptop. That's all right. Anyway, I highly encourage you to check out the Teachable Machine. Let's take a look at another demo. So this is a game called Quick Draw. And Quick Draw, that's disappointing. Quick Draw is an image classifier running in the browser. And this is a game. And the idea with Quick Draw is it will ask you to draw a certain object in under 20 seconds. And Quick Draw recently has gotten much, much more difficult, and I will totally fail to do this. But what's interesting is as you're drawing it, and this is running entirely locally, it's asking me to draw a garden.
Or suitcase, or envelope, or grass.
Maybe I can try and draw a flower.
Or jail, or stereo, or yoga, or
Right.
radio. I've
So what it will do is, as you're drawing, is it tries to classify the image. And what's cool about this, and the nice thing about TensorFlow JS, it's running entirely locally, meaning that no data is being sent to a server. And so machine learning in JavaScript, although it can be a little bit slower than Python, is a great way for completely private client-side ML. And what's nice about machine learning in JavaScript today is you no longer need to learn Python to do ML. Almost anything you can do in TensorFlow and Python, you can do entirely in JavaScript in the browser. So that's a big deal. It looks like this model has finally finished training. And let's see if it works. Yeah, there's something wrong with my laptop. But you can see it running live here. So if I step into the frame, you should see the orange progress bar jump up. Yep, and if I step out when I'm not there, you should see it go back to red. And so that's a computer vision model running locally, trained in the browser. Other cool things, we actually have a Pac-Man game in TensorFlow JS. And it works in a very similar way. If we had more time, maybe we'll do this in the workshop. I like to have people try this live. But what it works is you train 4 different gestures. So for instance, if my hand is in the frame, we're going to go left. If I'm out of the frame entirely, we'll go down and whatnot. And you can play Pac-Man with the camera. And so for instance, what I'll do here, apparently when I'm awkwardly in the screen, it's going to go up. When I'm out of the screen entirely, it's going to go left. And then I'll just put my hand in front of it for the others. We're not going to use those. Then you can train a model. And that model's done, or it's about to be. Yeah, I think this is my laptop having a bad day, but that's cool. So if I start playing, so when I'm in the frame, it should go up, and when I'm out of the frame, it's going to go left. So my plan is to go left and then up. So let's see if this works. Oh no, I think my laptop's, it's done. But anyway, highly encourage you to check out TensorFlow JS. And basically, to get started, this book is also great. It starts with scikit-learn. So as you know, deep learning is a subset of ML. And you can start with deep learning, but probably you should work your way through machine learning first, starting with things like k-nearest neighbors and decision trees and logistic regression. And this book does both. And it uses scikit-learn, which Andreas is giving a workshop on right now, which is by far the world's clearest and most mature machine learning library. It's outstanding. And then after that, it goes into TensorFlow too. So yeah, thanks very much, and look forward to seeing you tomorrow, and that's all I got.